Hello everyone, N3FJZ here with more ZX front panel work. It's been a while since I put a video up because I've been spending a lot of time implementing a modification to my parameter setting methodology, and involved quite a bit of change in the code and some in the schematic. But I didn't want to wait much longer since it's been a while, and usually I put a video up only after I've implemented a new feature completely, but in this case I'm still working on this, and so I thought I'd just give a quick update. Okay, what I've done here is I've added a new strategy for setting parameters. In the past, and let me get to one of these pages. For instance, this one's a good page to look at. You have several parameters here where you can set by turning the encoder, the rotary encoder, but to get to the next level down, or the next parameter down, you would have to actually press the GUI page, and it would step down, but then you couldn't go back up, so you had to go all the way through all your GUI pages again to get back to what you were working on to make the change. Okay, so that was just a limitation the way I originally set up the code, and it was sort of boxed in on that's how the only way I could do it. But I sat down the other day and came up with a new strategy which required a little bit of code changes. But now what I have, and this is just a I call it the configuration matrix test, where I just got some test values here. But now what I've done is I've implemented an up and a down key. So now if you press down while you're on the GUI page, you'll get the next parameter. And if you press up, you'll go back up to the other. It's more natural, I think. And if you change a value, you'll get an asterisk next to the name, the label name, to say that there's been a change from the original or from the value that's saved in the startup defaults. But if you put the value back, the asterisk disappears. Same way here, and so on. Also, what I've done is I've added an Enter Select button, so that you have soft buttons on the screen. And for instance, I've made a change to the crystal trim. Then if you hit the Enter key, while you have the Save Soft button highlighted, it will go ahead and save that to non-volatile RAM. So when you start the unit back up, that's the value that you'll get in the startup. Also, if you change a value, again, here's the asterisk indicating that you've made a change. Now, of course, you can dial it back to the original, and the asterisk will disappear. Or if you've gone through and you've made some changes and you're not quite sure that, you know, it's like, oh, I messed that one up. That's not the value I wanted. What was the original? You have a cancel soft button. So if you highlight cancel with the up and down keys, hit the Enter, it will restore all the values back to the originals, and you lose your asterisk. So that's what I've been working on. To implement this change, what I had to do was added two new buttons here. Well, I've actually expanded the button complement. Here I have 8 push buttons, momentary push buttons, and I've added the up and down, and also entered a cancel, escape, and an Enter Select button. And this is reflected in the schematic on the website, where I've sacrifice the channel 3 and channel 2 serial ports for 4 additional buttons. So we have 2 left for future expansion, and then the enter, select, and cancel escape buttons. The other ones are all wired the same, so there's no changes there. So if you wanted to actually implement this new menuing structure, you would have to wire in those additional, at least the 2 additional push buttons onto digital lines 14 and 15 on the Arduino Mega. So again, this is just a demonstration menu. This is not really going to be in the final production here. Now, what brought all this on was the need to provide a calibration feature for another feature that I've added. Let's see if I can get to that, which is it's a thermometer that will use common switching diodes to monitor the temperature of the 2 finals. Right now, at this moment, I just have these diodes. One's actually outside my window, which is the 58-degree temperature. And then, of course, here's the other, which I just have inside here. And, of course, these are just for development work. The final layout will have those glued to the top of the 2 final transistors on the PA. But the way this works is I found that there's so much variation between diodes that I had to provide a means of calibrating this, because it's a very coarse thermometer. It's not very precise. It's got I think it's a 2.2 degree per count resolution, or around a 4 degree Fahrenheit resolution between temperature counts. And you can see this. I'm just going to just kind of squeeze the diode. You'll see that final B temperature right now it's set, that's displaying 77 degrees Fahrenheit. It will go up, and you see it jumps right to 80, and then okay, I must be getting cold. I can't get it beyond that, but you get the idea. It's very coarse. But even so, if you use the normal formula, thinking that the number of millivolts per degree centigrade change was 2.2, it may or may not have come out accurate. So what I had to do is add a calibration feature where you have to, I haven't fully implemented this, but what we'll have here is that you will take, say, some hot liquid, you measure it with a thermometer that you own that you know is fairly accurate. You'll come up with what the temperature of that liquid is, and then if you then set the analog read counts to that temperature and then do another calibration point, in this case it was just ice water with some ice cubes, and stir it around a bit. That's a typical way of calibrating a thermometer for 32 degrees. So you would enter it at 32, and then of course the analog counts would be 126. So with those 2 points, the algorithm then can calculate fairly roughly accurately enough for monitoring PA final temperatures, in this case again 58 and 77. And I also have a way of setting the unit of measure to Fahrenheit degrees or centigrade or Celsius degrees, depending on what your preference is, and you'll also calibrate it using those units. But to do that, I had to come up with a way of having multiple parameters that could be dialed in. You insert your diode into whatever liquid you're measuring, let it sit a few seconds, and then you would have to hit a button, enter, to say take a snapshot of what the counts are at that moment to use that temperature. And it was going to be hard. It was going to be difficult to do it without designing a GUI screen that allowed you to actually set a value and then step down and then hit a button. In this case, the temperature will have different labels on the buttons, but you would then say, okay, here's my 32 degrees, and if you would hit enter, that would then take the temperature. Anyway, I just wanted to give a quick update. Once I get the menu fully implemented and the thermometer or the temperature monitoring parts of the code done, I'll put up a more formal video. Anyway, 7-3 to you all. This is N3FJZ.